So I'll share my screen here and let's get started. So first off, our topic for today, as Annabelle mentioned, was our Sql provision, and really that's ties into our protect and preserve data part of compliant database DevOps. So the idea here is kind of being able to protect and preserve that data, preserve kind of the structure, make it look realistic. So you have good test data, but not real, because we don't want to expose customer information to our developers or internal users or sales teams, even in some cases. Whoever is going to be using these data sets. And so some of the pieces that come into that is, first of all, knowing where that sensitive data is located. And Steve Jones earlier today did a demo with our data catalog tool that helps you catalog where that data, that sensitive data, lives inside of your database, and applying tags to the different column types. So marking, names as names, marking addresses as addresses, social security numbers as such. And then once we've identified where that sensitive data lives, we want to configure masking sets, masking rules to cover those particular columns. So replacing the data inside of those columns with data from data sets that we provide. And we'll see how we can integrate that data masking into Sql Clone here, since that's where Steve Jones kind of left off, was at data masker here. And then we're going to see how we can also integrate Sql Clone here with kind of your normal process, provisioning these databases out to developers, as well as integrating these virtual data sets, which is what Clone provides, with your continuous integration and your build and release process to help you kind of spin up copies of your prod database for testing, which is really useful. So we'll see that as part of this too. So first off, let's talk a little bit about Sql Clone on its own here. And let's actually dive into the documentation page, talk a little bit about the architecture of Sql Clone. So Sql Clone is really based around database virtualization. So we're actually virtualizing our data set to allow us to send that data set off to developers or whoever we need to send it to without it taking a lot of time to do that provisioning. So we don't have to do a full database restore every time we spin up a new clone database. And so that gives us the entire database size, 1 terabyte, without 1 terabyte's worth of space. So how do we accomplish that? So on our right-hand side here, you can see we have our source, and our source can either be a live database or a backup file. Typically, our customers will use a backup file, which is just a .bak file, your standard Microsoft tape format file. And then we take that, we restore it, we run a masking set against it, and that creates our image, our database image, which is really just a virtual hard disk that contains our database files, our raw database files inside of that VHD. And once we have that VHD, we can then just mount it over the network to our dev test QA instances, and it will look like those database files are on those servers, but they're actually located on our file share. We've just mounted them over the network to those locations. And alongside of that mount point, we spin up what's called a differencing disk, which captures all of the writes. So every time you edit this clone, edit this virtual database, that information is stored in that differencing disk. So if we add 5 gigabytes worth of data, it's going to grow by 5 gigabytes. And outside of this whole process that we have here, it's kind of end-to-end process, we have our Sql Clone server, which is just a web server that we're going to be interacting with to kind of orchestrate this whole process. And we can also automate this whole thing utilizing PowerShell. So we might see a little bit of that, but we're going to be just looking at the UI for the most part. And the idea here is really that we want to be able to automate, the majority of this, so that we don't have, DBA's time isn't wasted as part of this restore process, because that's what we see with our customers so often, is that DBA spends so much time just trying to give refresh data back to their developers. So we want to make it quick and easy for you guys. So here's a Sql Clone here. You can see kind of the dashboard. And I already have a bunch of images that I've created already. Some have already been masked. That's what this little green modified means here. And we can see the recent activity in here as well, the logs for each. So let's go about creating our virtual data set in here, our virtual database. And we'll see some tie-ins with SQL Data Catalog in here too. So let's do this from a backup file here. And I need to restore it to a specific server. So I'm going to restore it to my server here. It won't take up any space there because it's virtualized. It'll actually just take up space in my file share. And then here we go. Let's do our AdventureWorks here. And this is a .sqb, which is our proprietary, SQL backup format. So we support that as well. But we also support, .bak too. And I'll just hit continue here. And we also support, multiple files, database files. If we're restoring those, or if they're password protected or encrypted, we can, do those as well. And notice here in the classification tab, it says this database contains data that has been classified as confidential, GDPR, and confidential. Consider applying a masking set before creating the image. So this is the tie-in with data catalog here. So Sql Clone, we haven't even looked at data catalog, but Sql Clone has. It's talking with our data catalog tool, and it's looking at this database and saying this database has had these tags applied to it already, confidential GDPR. You need to apply a masking set to it. Otherwise, if you create a clone off of this image, it may contain confidential information, which we don't want. We don't want our developers getting that. So I'm just going to hit continue here. And now we get the opportunity to add a masking set. So I'm going to pick up one of the masking sets that I've already created for my AdventureWorks demo here. And I have these masking sets here saved into Git. I already configured these, using my data masking tool here. And we can take a look at them if we want to towards the end. But suffice to say, this is XML in here that describes which columns we're going to be targeting and what data sets we're going to use against those columns. Cool. We can also drag and drop SQL scripts in here too to modify the target database that we're restoring here before it's provisioned off to developers. So that might be to remove prod permissions too before we give it back to lower environments. And then I'm going to hit continue here. And let's put this off to a file share. So here's my UNC path for my file share location. And then we're going to assign this to a specific team. This is going to be for our dev team here. And you can see I could give this to my QA team as well. And this allows us to assign access to these images. So if you have images that are for a specific team and not for another, we can kind of have those roles and those permissions created and assign access to them. So that's pretty powerful as well if you have a number of teams working with a data catalog here, or SQL Clone here. So we'll do 1111, lucky day here, 20, cool. Create image. So now it's going to be doing the full restore, and we can watch that happen because this is pretty quick. AdventureWorks is a relatively small data set here that we're working with. So the restore isn't that bad. Suffice to say, though, we're doing a full database restore, so this is going to take as long as a restore. And a little spoiler here, this one's actually going to fail here in just a second. We'll see that. There we go. So it actually failed during my masking set. And In the masking set itself, it's just doing some very simple data manipulation. So it's only doing update statements essentially, or insert statements. It's not doing anything that would actually invalidate the schema of the database itself here. So we're not messing up our database or making it invalid in any way as part of the image creation process or the data masking process. So why does it fail and not produce any image here? Well, that's really because if this was part of an automated data delivery platform to those developers, we don't want sensitive data being automatically exposed back to those developers. So we don't want that, the other end of that pipeline, to pump out, sensitive data to our developers. And so that's kind of a safeguard there. If you have this, running on a nightly basis, and for whatever reason your masking set, fails to mask something that it was designed to, either because it ran into an error during the masking set or something like that, this is the error we'll see, and no data set will be provided to the developers. So because of that, let's actually go off of another database in here. Maybe my widget role prod that's already been modified already. So it's already been masked, and I already have a bunch of clones for this one too that are at various sizes. And let's create another clone off of here too. We can modify this clone as it's being spun up using a template. So the idea here is to modify it for the environment that we're sending it to. So essentially, that we're essentially, if the target environment needs specific permissions, like for example, we need to add development or test users to the database itself, we can add them with the template here, or add in seed data, make any sort of modifications for this particular environment that we're sending it to. But I'm going to skip that for now. Here we go. And here's my destination. So this is the server where I'm spinning up my clone. And my clone here is going to have the same name that I give it. So this is going to be the database name here. There we go. Because it is the database name, we can't have two clones with the same name on the same server. And let's see, that might have been, oh, here we go. This is actually a different issue here. So let's take care of this. There we go. Okay, and let's do that quickly again. So that was actually my VPN, because it checks your credentials when you're doing this. Okay, so now it should create just fine. Okay, let's try that again really quick, just to make sure. Okay. Let's see. And let's do a slightly different name here, just to make sure. We've been trying this. Okay, there we go. That was weird. Okay. So now that we've tried it with a different name, here we go. Here's our widget dev 10 right here. And you can see that it was already linked up to source control. So I've already, linked my widget dev 10 here up to source control. And so it's automatically linked up to Azure DevOps. And now I can just start making changes to my database, checking that into version control. Before I do that though, I actually want to get the latest changes from development and apply them to my clone here. So let's do that really quick. I'm just going to the Get Latest tab, and we'll deploy everything from our repository to my database, which it looks like not very much. Cool. And then let's make a change to my database really quick here. And let's do let's do contacts here. There we go. There we go, in varchar. $50. And let's just execute that directly here. And then let's go back to SQL source control, go to the commit tab and check that in. And then that'll kick off a build and release here out to another environment. So here we go. Here's my contacts table. I don't care about a lot of these, but I'm going to check that one in. And I'll associate this with the TFS work item, so hash A5 to associate this with TFS work item number 5. Commit that directly here. And then now it's going off to Azure DevOps, as I mentioned before, and we can take a look at that as it's building here. And I actually have Sql Clone tied into my build as well. So I mentioned that Sql Clone is great for spinning up data sets for test data management. And so because we're cloning the entire database and we have the entire database sans sensitive data at our disposal, it kind of looks and feels like a production database, and we can kind of treat it that way. So as part of my build pipeline here, I'm doing several layers of build. So I'm doing an initial validation, validating all the scripts inside of my source control repository, utilizing SQL change automation build here. You can see this is just a plugin for Azure DevOps. We can get it straight from the marketplace. And then I'm running all of my tests in here too, my unit tests. And then in here, I'm actually creating a clone of the latest copy of prod. So I'm utilizing that widget role prod here again, and then I'm deploying directly to it because that widget role prod represents the latest copy of prod. So it's kind of like a deploy to staging on every build here. So it does that deploy to staging before it ever goes out to a downstream environment. And I could even, use this clone here as the back end for an application. So I could do an application build in another task down here on top of this, clone here, and use this as the back end. And I could, do some integration testing on the actual application itself, since we have a prod-like data set to work with. So it gives you a lot of options for being able to do really rapid testing, being able to spin up and self-serve whole data sets on the fly. As you saw, it was pretty quick to spin up a clone there. And then after we have that whole data set, we can easily refresh it and drop and create it, do whatever we want with it. One thing that I've talked to a lot of developers about is it's really useful to be able to drop and recreate the database, to be able to try something against a prod-like database, try something experimental, adding we can see this being kicked off right here, where it's deleting and creating clones here. You see how fast that's happening? That's actually Azure DevOps running right now, doing that drop and create here. It does that on every build. So that kind of rapid refresh allows us to be experimental, to try things, to not worry about breaking the database, because it doesn't matter. We can just spin up another one. We can drop this one, spin up another one on the fly, and we haven't lost anything. All of the important code is stored in the repository. It's stored in source control, as we saw, and that really makes the repository version control our source of truth, which is really a DevOps best practice. We want the repository to be the true source of truth, because it's got an auditable history in there. Who made what change when, and we can keep track of versions really easily in there. Comment and branch and merge. Git is so powerful. So we really can't take advantage of that branching and merging unless we can branch and merge the database as well. And Sql Clone really allows us to spin up new copies of the database for new branches if we wanted to, and play around on those branches and have prod-like data sets the whole while. So it's quite a powerful solution, and I think we have some time now where you guys can ask some questions if you want, or we can take a look at some other pieces too if we want to dive more into Data Masker, or even take a look at Data Catalog, because I know that was mentioned in the invite here. And I want to take a look at that if that would be valuable for you guys, but if not, we don't need to. So.
So feel free to raise your hand if you want to go live with a question, or type the question into the chat or question and answer box, and then that way Andrew can answer your questions live. Yeah, we've got about 10 minutes. Otherwise, maybe Andrew, if you want to start with the next demo.
Sure. So I mentioned that we're doing the full build here. So our build was successful. We built from scratch to an empty database inside of Azure DevOps here. This is all just PowerShell under the hood. And the test here, we ran all of our unit tests as part of this process. And then we deployed to that clone immediately after creating it. Like I mentioned, a deploy to staging. So after that, we really have our releases here, where we're deploying out to our test environment here automatically. So it's automatically deploying to test. And then we have a manual intervention process here before we actually deploy to our UAT environment, because we don't want to deploy to UAT where we have users. It's called user acceptance testing. We actually have users who are playing around with that code in that environment. So we want to review it and intercept that code before we deploy. So here's for my UAT environment. Here's the update script right here that it's going to run. And here's some reports here. So let's take a look at this report. This will let us know what's going into UAT. And this is really important, is to have really good visibility. So a key part of database DevOps is increasing visibility at every step of the way. So obviously, inside of SSMS, we have SQL prompt, which we really haven't discussed. That gives you visibility into the code itself, code formatting, static code analysis, other things in there. And then, with source control, we have auditability. We have who made what change, when they made that change, what objects they changed over time. So kind of a history of the database inside of version control. And inside the release here, we actually have a report letting us know what's going to be deployed, any issues with the code, and a bunch of checks before we actually go out to our widget UAT environment. So in here, you can see it takes us initially off to our Sql Compare Warnings tab, where we have a high warning. So it's saying, this deployment will actually drop these columns data in these columns will be lost unless additional steps are taken to preserve it. And we can go see what those changes are in here too. So you can see in the Changes tab, we have kind of a nice summary in here of what's being added. Okay, adding a procedure, adding 2 procedures, it looks like, removing a bunch of procedures in here, and then also modifying in here too. So you can see where we're adding a column, a new demo email column there, and then removing some columns as well. So this gives you kind of just at a glance, a clear idea of what's being deployed. You know, we haven't even looked at the SQL script yet, but we have a pretty clear idea of what it's going to look like just based on this report here. And this really gives us a good before and after too. You know, inside of the script itself, it'll just say drop procedure, you know, get DM_employee. But we don't know what that procedure looks like. We just know that it's being dropped. And so maybe being able to see, you know, the syntax of that procedure might let us understand whether that's a good idea or not, whether we actually want to drop this, you know. And same with the columns too, being able to see what columns were there before, what columns are there afterwards, the before and after in here, to better understand kind of the effects of the deployment. And then we can go to the script itself over here too, and we see all the drops in here. So this is what's actually going to be deployed. And you can kind of tell that this is done by our compare engine under the hood. There's a lot of error checking in here. And then we have some static code analysis. So you can see that it's highlighted this bit of syntax here. And I'm not entirely sure why, but let's go see. So we've got, here we go, let's click on this. So it says 3 and 4 part column references in select list are deprecated. And we had a bunch of 3 and 4 part column references in there. Schema.tablename.column name. So that's our 3 and 4 part column reference. And then we have an unqualified column name as well. So we just have a column name without the table name. So we can't quite get that right, it looks like. And then we also should be using an alias for our table source as well. And these are all the rules that passed in here. So these are just a few of the code analysis rules. We check for around 90, 88 to be exact here. So things like asterisk and select list, select and trigger, that'd be bad. Delete statements without a where or inner join clause, which could cause a lot of data loss really quickly in here, as well as things that could cause security issues. Like for example, we can detect implicit SQL in here, which is used for SQL injection attacks, or I should say dynamic SQL, as well as other things in here, old style top clauses, hints, all sorts of stuff. So anyways, once we've reviewed this report here, we have a pretty good idea of exactly, you know, what's going to be deployed, the potential issues with the deployment, and what the database was like before the deployment too. So we can kind of intelligently choose whether we actually want to deploy or not. And that's really key to having successful releases. You know, by the time you release to prod, it should be boring because we should have so much visibility into the code itself, and you know that it's validated against, you know, good data sets before it actually goes out to prod. And this should just be a push button, you know, type a comment in here, click resume, and then deploy out to our downstream environment. Cool. And we can take a brief look at data catalog too. We only have 1 minute left here. No, I think that's probably good for now. Yeah, so feel free to ask any questions in here. I think we're just about to the top of our time here. I want to thank you guys for joining us. And please reach out if you do have any other questions, or if there's something else you'd like to see that we didn't cover today. You know, do let us know, and hopefully we can cover that in a later conversation another time. So thanks so much for having me here.
Thank you, Andrew, for talking us through. That was a really great demo, and hopefully everyone else found that useful as well. So we will let you get back to the sessions during past virtual summit, unless you have any questions, but please do feel free to come and see us on the booth. Lots of us are there ready to have one-on-one chats with you if you'd like. We've got demos happening tomorrow and also on Friday as well, if you want to see the Sql Toolbelt or Sql Monitor from some of Andrew's colleagues. But thank you very much for joining us. It was lovely to have the opportunity to talk with you, and we wish you a great day.
Yeah, enjoy PASS, guys. Take care.
Thanks so much.